Okay, here we go. We're going to start Unit 6. This is on polynomials. Polynomials is probably a big reason for this class, especially once we get into factoring. So that's kind of knowing how to handle polynomials is a big part of mathematics. So take this one pretty seriously, I hope. So we're going to start with just messing with polynomials, then we'll move into the factoring after that, and then we'll do a couple other things that you might not have seen. So the first one is we're just going to add them. So when we add them together, it's no big deal. I've got one polynomial first. In this case, I got a binomial and a 4-term polynomial. All I got to do is combine like terms. The plus sign isn't really going to change anything. So what I always do, I put an underline underneath the ones that are the same degree. Has to be the same variable and the same power. So that's going to be 1 minus 1. Those are going to cancel each other out. Looks like I got some squares here. So that's going to be 5 plus 6. That's going to be 11m squared. And then the other ones are all by themselves, so minus 8m plus 2. All right, that's how we add them. You can do that 100 times. I'm sure you've seen it a million times. Now, if we're going to subtract, though, we got to remember that negative is going to distribute to every term in that parentheses. So we're going to say 7 minus 8n. None of this changes in the first term, but the second one's going to be negative 5n squared. Minus, so that's going to be plus 5 minus 3n. It distributes to all. Now I just got to combine like terms, just like we said. So I always like to start with the highest degree so that it's in descending order. It looks like it's in standard form. So it looks like I got no cubes, only had 1 to the 4th power. So that looks like minus n squared. I got an n here and an n here, so that looks like minus 11n. And then I've got 7 plus 5 is plus 12. So there's my answer for that one. You might see this a couple different ways. You might see some taught vertically where you just kind of line them up. I do that a little bit sometimes. I'm going to show that when we do one in a little bit when we multiply. But there's a bunch of ways depending on the book or the teacher or whatever it is that you're looking at. All right, let's move on to multiplying. Let's find the products of these. Now, this is just distributing. We've got a monomial times a binomial in this case. We're going to distribute, so this is going to be 8x minus 28. The biggest mistakes I see is when somebody says 8x minus 7. They only go to the first term. Got to go to both terms. So same thing over here. I've got 40x minus 35. I'm distributing to both terms. I'm going quick on this because I know you've seen that before. Now we're going to multiply these guys. I got 2 that I want to multiply out. We're going to use what we call the FOIL method. I don't really like the term FOIL. I like the term freeze and distribute, but I'm going to go ahead and just say FOIL on this one. And that's first, outer, inner, last, right? So the first 2 terms are this right here. 16n squared, multiplying those together. Outer is going to be these 2, so that looks like minus 32n. Inner, so plus 4n, and that last 2 terms is going to give us a negative 8. Don't forget to combine like terms, so 16n squared minus 28n minus 8. That's how we multiply 2 binomials again. Let's try it again. 7n times 4n, that's going to be 28n. 7n times 2, so plus 14, I'm sorry, that was n squared, pardon me. 14n plus 32n, 8 times 4 is 32n, plus 16. We can combine these 2 like terms, so 28n squared plus, looks like 46n plus 16. Ta-da, there's our multiplying 2 binomials together. All right. What if we have a trinomial? Here's what I like. This is a binomial times a trinomial. Here's what I like to do, and that's I kind of alluded to this before, but I got to distribute this to this to this, and then this on the bottom. Kind of looks like a clam shell, kind of. But anyway, 5r times negative r, or negative 5r times negative r squared. So that's going to be 5r cubed, then minus, so plus 20r squared, minus times a positive, so minus 15r. That's the top part. Now I got to do it again. I'm going to go, let me change colors. I'm going to go this one, this one, this one. I'm going to line them up underneath. So it looks like 1 times negative r squared. So minus 1r squared minus 4r and then plus 3. So now they're lined up by term. Now it's really easy to just say, okay, let's add them together. 5r cubed plus 19r squared minus 19r plus 3. There's your answer. Now you could have just kept writing along and then combined like terms. That would have gotten you to the same answer, but I don't know. I like to do that when things start getting bigger, especially if it's a trinomial times a trinomial or even bigger. Then you really need to keep that organized some way. Some people even do the box method to keep things organized. And if you want to know about that, ask me in class. All right, so the next 3 are kind of important. The next 3 are going to show us a pattern that we're going to use for a long time. We would call this the word conjugates. Okay, these are conjugates of each other. And what I mean by a conjugate is that these two have the same first term, have the same second term, and they are then, one's a positive and one's a negative. So if we were to just to FOIL this or just do it, regular multiplication, we'd end up with 16v squared minus 28v plus 28v minus 49. But what's going to happen is these two guys cancel each other out every time. So that gives us 16v squared minus 49. This right here, this piece is called a difference of squares pattern. Okay, those are conjugates, and when you take two conjugates, multiply them together, you get a difference of squares. We see this pattern all over the place in mathematics. Okay, so it's important that you know it. And even you can kind of save yourself some time. Let's go on to the next one. I know these are conjugates of either 5k, 8 minus plus. So I don't even need to do the other part. I can just say, okay, this is going to be 5k squared minus 8 squared. You don't even have to write this. I'm just writing it so I know. It's got to be a minus sign in the middle, right? So this is going to be 25k squared minus 64. That's it. That's my answer. All right? You don't have to kind of mess around with that. But recognizing that pattern is so important. And we're going to need to recognize that pattern as well when we factor, okay, which is going to be in just a minute. All right, so this one, 2 times 2 is 4. X times x is x squared, minus sign in the middle. I know it's a conjugate. I know the middle terms are going to get blown away. So no problem. No problem. All right. Oh, same thing here. 8x times 8x, 64x squared minus 25. All right, great. I got to answer this. All right, sorry. Got to get that done. Okay, so now let's go on to another one. What if I have a binomial and I'm going to square the quantity of the binomial? I'm going to tell you the most popular bad answer, the one I don't like, is people just say, okay, well, that's just 2p, square that, minus 4, square that. No, that's not how that works. Even if this was a plus, they turn this to a plus. That is not how this works. It is not the difference of squares pattern. This is, you have to think of this as if it was like 2p minus 4 times 2p minus 4. If that's the case, the middle term's not going to get blown away, right? So if we multiplied this out, it would be 4p squared minus 8p minus 8p plus 16. So that's going to be 4p squared minus 16p plus 16. Now that is what we call a perfect square trinomial. Okay, what that means is when I say a perfect square trinomial, and this is important, this is a perfect square, this is a perfect square. And if I take their square roots, which is 2p, and multiply them together, 2p and 4, that's 8p. If I were to double that, it gives me that 16 in the middle. That means it matches and it is a perfect square trinomial. Okay? So you can use that pattern to do this a little easier. Now, you could do this every time. You could do this and multiply it out like this, combine like terms like this, and you'll get the, as long as you don't make any mistakes, you'll get the right answer every time. But you can also use the pattern to make this go a little easier. So I know that this is going to be my pattern. My first term is the first term squared, so r squared. My other one is my 1 squared, so that's fine. This plus sign goes here, so this is going to be a plus sign. I'm going to take 1 times r, and I'm going to double it. So it's going to be 2 times 1 times r squared plus 2r plus 1. That's what you're going to do every time. That's the pattern. Wasn't that a whole lot easier? If you can see the pattern, that's math, by the way. All math is patterns. Let's try this one. Let's do the same thing. So I got 6x. I got to square that. I got my 1. I'm going to square it. This is a minus sign, so there's a minus sign here. This is always going to be a plus sign. It's going to be like a negative times a negative, so it's always going to be a plus sign. All right? So now I just take 2 times the 6x times 1. So this is going to be 36, kind of clean it up. 36x squared minus 12x. Oh, I'm sorry, this is squared. Plus 1. 1 squared. All right? All right. Same thing. Try this one on your own. I'm going to pause for a second. Send this text. Did you see my email, by the way, about who to make the check out to? Question mark? All right. There was our break. All right. So 7n, we're going to square that. 6, we're going to square that. Minus sign, always a plus sign. I'm going to take 2 times 7n times 6. 49n squared minus, let's see, that 7 times 6 is 42. 42 doubled is 84n plus 36. There's my answer. All right. So if you can recognize those patterns, I think it'll make your life a whole lot easier, especially on the factoring side. And that's what's going to happen here in just a little bit. In fact, how about right now? Okay, so now we're going to factor. We're going to start factoring. The number one thing you always start with every time is check to see if there's a greatest common factor. There may or may not be one, right? There might not be a greatest common factor, and then you just move on. In fact, often there won't be one. So this one, what looks common? I think there's an 8 that's common. This is just number sense. Hopefully you're there with that. So that's going to be 10 minus 7b. I can factor an 8. What's common? What can I pull out of there? What can I divide each one by? That's going to be the same. All right. All right. How about this one? Well, what's common? We're only looking at GCS right now. Well, hopefully you see the factor of 7. Also, there's some m. So what if I pulled out 7m squared? Now, here's another thing. The leading coefficient is negative. You also might pull out a negative. You don't have to in this case, but when we're factoring beyond that, you probably want to because that's going to make things a little easier. So it's as if now we're adding the parentheses back. It's as if we're dividing everything by 7m squared, divided by negative 7m squared, divided by negative 7m squared. So I end up with what? 6m to the 5th minus 7m minus 8m, no m's. Okay? Now then later on, you might see if you can factor that trinomial that's left on the inside. Of course, this one we can't. All right? What's common with this one? Looks like a 5 and an x squared. Okay, so I'm going to factor out a 5x squared. I know I'm going to have stuff left over here, so 5x squared I'm taking out, minus 5x squared. Divide each and everything by that. And sometimes you might like, oh, wait a minute, there's more in there. You might have to do it twice. That's okay, but it's better if you can get it all in the first shot. Looks like x cubed. Looks like minus 10x squared plus 4x plus 3. And I think we're done. All right, so always, first thing you should do, look for that GCF. All right, let's go on to the next ones. Now we're going to try and factor binomials and trinomials. These first set are going to lead right into what we just talked about. You need to, okay, if we have a binomial, we're going to have 3 possibilities of what it could be. It could be the difference of squares, a difference of cubes, which we'll learn at the end, or a sum of cubes, which is also part of what we'll learn at the end. So right now, if it's a binomial, you need to check to see if it's a difference of squares. And by that I mean, is this a perfect square? Is this a perfect square? Meaning if I can take the square root of it, is it nice and neat? Yeah, it is. So this one's going to do that pattern that we talked about before, but in reverse. So we know that pattern is, a squared minus b squared equals a minus b, a plus b. So we're going to do the exact same thing. The square root of 25n is 5n. So that's going to go here and here. And the square root of 1 is 1. That's going to go here and here. 1 has to be a plus. 1 has to be a minus. Order does not matter. Okay? All right. Same thing for the next one. Oh, 16, that's a perfect square. So I can go 4v. 25 is a perfect square. That's 5. That's 5. Plus and minus here. Now the trick I'll do is maybe I'll throw this problem in here and I'll put a plus sign there and see if you notice. All right? Don't fall for that trick. Don't fall for that trick. All right? Same thing here. 25 and 4, both perfect squares. K squared, perfect square. So I'm going to say, okay, this is going to be 5K. 5K. The only 5K you'll get out of me. 2 and 2. Minus plus. Have to be opposites. All right? And this is almost the same problem, so I'm just going to skip it. It's just 4 instead of 2. All right, now we're going to get into the trinomials. Now, the first thing I want you to check when you do trinomials, again, still always look for that GCF, but I want to see if you have a perfect square. If you can recognize that it's a perfect square trinomial, you're going to save time over time. Now, you could just factor this like I'm going to teach you later, just any old trinomial. But if you can recognize it, say, hey, the square root of r is r. R squared is r. The square root of this is 5. Hey, 5 times r is 5r. Double it is 10r. Hey, that fits the pattern. That fits the pattern. There's a minus sign here. That's okay. Plus sign there. It has to be a plus sign. So what you can do is you can say, okay, that's the a squared plus or minus, and that's that 2ab plus b squared, equals, and that's going to be a plus or minus b quantity squared. So when this factors, I know right away that's going to be r minus, because that's a minus, 5 quantity squared. The square root of 25 is 5. The square root of r squared is r. If it fits that pattern. If it doesn't, if that 9 was or that 10 was a 9, doesn't fit. Doesn't fit. All right. Same thing with this one. Let's keep going. The next one. This is square root of this is 2. Square root of this is x. 2x, double it 4. Oh, no problem. perfect square trinomial? It's going to be some quantity squared. Square root of x squared is x. Square root of 4 is 2. Plus sign. That's a plus sign. It comes straight down, plus sign. That's it. So x plus 2 is your answer. Okay? Let's try this one. Ooh, getting a little more complicated. 9r squared. Okay, the square root of that is 3r. Square root of 25 is 5. Hey, 3 times 5 is 15. R, double it, 30. It worked. So I got 3r, 5, quantity squared, minus. That's simple. Okay? Okay? I hope we're seeing this. If you have trouble, and here's the thing about this. If you miss it, it's okay. You'll catch it the other way. You might just at the end say, oh, it's one of those. I could have done it real fast. Square root of this one is 5n. Square root of this is 1. Double it. That's 10. So this one's going to be 5n minus 1 quantity squared. All right. Now we go on to the next one. We're done right away. 40 is not a perfect square. So we're done. It doesn't work. It doesn't fit that pattern. We're going to have to do something else. So I'm going to teach you the way I like to do it. If you have 10 teachers in a room, I bet you could find 10 different ways to teach factoring. I like the slip and slide method. So that's how I'm going to teach you how to do these ones. We may not do all of these, but we're just going to, we'll be okay. Now this one is it has an a of 1. There's a 1x squared there. So that's fine. That's fine. That makes this a whole lot easier. All I got to do is I know this is going to factor to something, 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 something. I got an x here. I got an x here. Hey, this is plus, plus. So I know it's going to be plus and plus. I just got to think of the two numbers that I multiply together to get that multiply together to give me 40, that add together to give me 13. A lot of you have already done this in your head, I'm sure. The answer is 8 and 5, right? 8 plus 5 is 13. 8 times 5 is 40. Now, there's a couple ways. If you're, let's say you're having trouble getting there. One thing we like to do is we make this little x, and we say, okay, let's see. I want to multiply together, get 40, add together to the 13. So that's where I got the 5 and the 8. What if you had trouble getting that? Here's the way I like to go about it. I just start at 1. Well, what times 1 gives me 40? Well, 1 times 40. Okay. 2 works. 2 times 20 is 40. How about 3? Does 3 go into 40? No. 4 and 10? No. 5 times 8, that gives me 40. 6, no. 7, no. And now 8, I'm already back here. I've already kind of worked my way back around. So those are the 4 different ways that I can get 40. How do they add up? The one that add up to 13? That one right there. Now, if that was a minus for 40, you got to see which one has a difference. Okay? One has to be positive, one has to be negative. All right, let's keep going on that. Here's a good one. Okay? So what two things add up to -4, but multiply to get 140? So I know this is going to be P and P. I know one has to be positive, one has to be negative because of that negative right there. So I could do the whole thing. I don't really need to, but 1 and 140, 2 and 70, 3 doesn't go into there, 4 and 35, 5 and let's see, 28. 6, I don't think goes in there. 7, I don't think. Oh, yeah, 7 goes in there. 7 and 20. Notice the difference between those two is getting smaller, though. Let's see. 8. Does 8 go into 140? I don't know off the top of my head. Let me see here. Big number. No. 9, no. 10 and 14. Oh, look at that. That has a difference of 4. So one of them has to be 14, one of them has to be 10. Now, which one's got to be the negative? Well, it's more negative than it is positive because of this minus sign here. So we're going to put the 10 here. We're going to put the 14 there. Okay? And now you're looking at it like, oh, 10 and 14, of course. What are you doing? Don't make a mess. Just like 5 seconds. All right.
Put it in for 5 minutes.
No, 5 seconds.
5 seconds?
Yeah, 5. Just hit a 5 and hit enter. All right.
I hit 5.
Okay.
I hit 5.
Okay. Why don't you come over?
It was too quick.
That's plenty. Come on. All right. So if you're good with your numbers, though, hopefully at some point you kind of just can just do this. So it's, let's see, 42. How can I add up to 42? 1 and 42. Well, that's 43. That's too much. 2 and 21. No. 3 and, ooh, that sounds good. 3 and 14. Hey, there it is. 3 and 14. Right? Oh, that's perfect. Give me a scissors.
Okay.
Sorry. Somebody needs a Kogert. Scissors.
Yeah.
They're in that drawer.
I'm giving you not the soft ones because the soft ones I don't want to give you hurt.
Oh, you won't get me hurt. Okay, thank you. All right. Go downstairs. I'm working. Okay, thanks. All right. Those just kind of go on that. I think I'm going to stop the last one. I think you can do that one on your own. All right, let's go to 31. Now here's where I'm going to use a new method. Now, first thing, I see that 3 in front of the p squared. I'm like, okay, is there a GCF? There's not, because 2 is not divisible by 3. So here's what I'm going to do. This is what we call the slip and slide method. I like this because it makes it look like the other ones. So what I'm going to do is I'm going to take this 3 and I'm going to move it there. I'm going to slip it down to there. I'm going to multiply. So that's p squared minus 2p minus 63. Okay, so now I'm going to factor that just like we just did. That's going to be p, how about minus 9, p plus 7, right? That was a little more convenient, right? But you think, can we just do that? No, we're not really allowed to just do that. So I got to bring that back. I got to divide by 3. So I'm going to divide this by 3, and I'm going to divide this by 3. So what that means is I'm just going to have to kind of take care of it. So 9 divided by 3, that's just 3. So this is going to be p minus 3. 7 and 3, that doesn't work, right? So you have to bring that 3 forward. It's going to be 3p plus 7. Okay? Now, again, some of you were brought up by kind of the guess and check method. That's fine too. If you want to do that and you can get to the answer, that's fine in your head. I just want to give you a method that you can use that's going to work regardless of how large the number is in there, regardless of the GCF. You know, just a something you can grind through. All right, let's do that again. 5 times 3 is 15, so I'm going to say v squared, no GCF again, by the way, plus 8v plus 15. So this is going to be v plus 3, v plus 5. But here's where just doing that, now I got to divide by 5. That's where the mistakes happen. So just, I know 5 divided by 5 is 1, so v plus 1. And this one does not, so 5v plus 3. And there we go. Always reduce it as much as you can. Now the numbers can get a little bigger. So this is where it might get a little crazy. So this is going to be x squared plus 64x minus 420. Eek. All right, well, we got to think about that. Let's see, that's going to be, I mean, obviously we can do the whole thing, 1, 420, 2, let's say 10. We got 10 and 42. Is that going to work? That did not have a difference of 64. How about 5? 420 divided by 5 is 84. So that's not quite enough difference. Somewhere between there. 420 divided by 6. 76 and 70. There it is. All right, that's my set. It's got to be more positive than negative. So this is going to break into x plus 70, x minus 6. That's going to give you the trinomial right above it. But Have to divide by 7, have to divide by 7. All right, so x plus 10, 7x minus 6. There's your answer. Okay? It can get a little big and tricky. All right? I don't want to do all these. Let's do this one. I'm going to slide the 4 over, so I got a squared minus 33a minus 240. So let's see, 2, no. Let's see, 4 times 80, no. 5. Oh, this is 280. I'm sorry. 280. So let's see. So it's not 10 and 28. So it'd be 9, no. 8. This is 280 divided by 8. Yeah. 8 and 35. So that's going to be a minus 35, a plus 8, because it's more negative than positive. Got to divide by that 4 now. So this just becomes a plus 2. This is going to be 4a minus 35. Ta-da. All right, I think we did enough of those. Recognize here, I've got a GCF. 20 or 30. You know what? Let's do this one. I got a GCF. It looks like oh no, I don't have a GCF. Oh, I do. Pull out a 5. So if I pull out a 5, this is going to be 6a squared minus 13a minus 15. So now I'm going to factor kind of just this part, right? So the 5 just kind of comes along for the party now. So this is going to be a squared minus 13a minus 15 times 6 is what, 90? All right, so what has a difference of 13? Let's see, 2 and 45, 3 and 30, no. 5 and 18. How about that, 5 and 18? Okay. So that's going to have a different, so this will factor to a minus 18, a plus 5. That 5 still hanging on. We're going to divide both of these by 6. Divide by 6. So it looks like our answer is 5a minus 3, 6a plus 5. And again, if you're fine with the whole guessing and checking, knock yourself out. Just make sure you get those GCFs out of there first, because that makes your guessing and checking 10 times harder if you don't. All right, tell you what, let's try a factoring by grouping. Now we have 4 terms. Now those of you that have already taken Algebra 2, like this 4 terms is easy, but you can get into 5 terms and 6 terms. So we have a method. This method might not work when you get into Algebra 2, and you might have to try something else. There might be some other solutions in there. All right, so first thing I want to do is make sure everything's in order, okay? Descending order by degree, this one is. So what I'm going to do is I'm going to group it this way and group it this way. So what can I factor out of the first group? Well, v squared. And I'm left with 4v plus 3. What can I factor out of the next one? Well, it looks like, let's see, 6. So plus 6. So that's going to be 4v plus 3. Not surprisingly, those two things matched. So that's going to be my first term of what's factored out, 4v plus 3. And then I call the rest the leftovers, v squared plus 6. It's kind of like you treated this like a big binomial, where this is the first term, this is the second term, and we factored out the v plus 3 part, and then what was left over, the v squared plus 6. Now, you always want to look at that v squared plus 6 to see if you can factor that any further. This one you can't, but it could easily be a difference of squares or a difference of cubes that we're going to learn out later on. So make sure you look at this part and see if we can factor that anymore. All right. Okay. Let's try this one. All right. So we're gonna group it together. It was already in there. Down. Doesn't look like there was a GCF in here. Looks like almost 2, but no. Almost 3, but no. So it didn't work out. I'm going to factor out a k squared. And that's going to give me, a 2k squared. That's going to give me 5k minus 6. I'm going to factor out a 3. That's going to give me 5k minus 6. So 5k minus 6. My leftovers 2k squared plus 3. Okay? All right. I like this one. This is a good one to do. Let me go orange. So no GCF. Notice here, factored out from the first group, looks like 8p squared, right? And I'm left with p plus 5. For the next one, there's nothing to factor out, so I'm really still left with p plus 5. But I still got to factor out something. I still need to factor that out. Put a 1 there. So now when I do that factoring like this, I've got 8p squared plus 1 times that p plus 5. Okay? The big mistake you'll see there is it'll be 8p squared times p plus 5. That's not right. You gotta count that term on the p plus 5. All right. I think kind of the same thing. I think I'm going to go just right to number 44. All right. So first thing you should notice, there's a GCF, right? Looks like we're factoring out a 5, I suppose. All right. So that's going to leave me with 5. So it's going to be 20x cubed plus 60. So that is 12x squared minus, 20. 2175. I think I got that. $175 divided by 5. I'm going to make sure I'm right. 35x minus 21. Now here's the deal with this. Now we got to factor the part that's inside. The 5 is kind of out of the way now. But here's the thing. When you do this, I'm going to group this with this. You're going to kind of group the negative with the second 2 and put a little plus sign right there. Okay? I usually say don't say plus negative, but this one's a different case. Because now on the first part, I'm going to factor out, looks like a 4x squared. And that's going to leave me with 5x plus 3. Now I got to factor out, I'm going to factor out what am I going to factor out here? This is not work. Oh, I didn't. Did I do that right? 21. Well, this one doesn't appear to factor. 20, 12, 60, x squared plus 35. You know what? This one doesn't factor. This one does not factor. It looks like it should, but it doesn't. 4x squared, 5. What? What did I do wrong? I did something wrong. I hate to say this, but I like this when I make mistakes because it makes so 20, 60 is 12x squared minus 35 minus 105. So 20 20x squared minus 21. 20x squared minus 35x plus 12x. What did I do wrong? Oh, it's a 7. Good grief. Why can't I see that? Factor out a 7. I couldn't. Oh, that's crazy. 5x and plus 3. We factored out a negative 7. Sorry. Why couldn't I see that 7? I'm really tired, actually. I've been up all night. Anyway, so now when we take out the other parts, so we're going to have 5. We're going to factor out the 5x plus 3. The 4x squared minus 7 is the leftovers. Don't forget to bring down the 5. But the big thing was you had to factor out that, just one, you had to factor out that negative 7 there. Make sure that it's the negative and do the plus kind of thing. All right. There's going to be another page of notes. It is going to be the difference of squares and sum of squares. So we will get started on that. I would do some of the homework now and then maybe head on to the next note packet in a minute. All right.